Hello guys, so in this video we're going to be looking at synaptic transmission. Now what is synaptic transmission? Synaptic transmission is just the sum total of the events that happens around the synaptic gap and the presynaptic neuron and the postsynaptic neuron. All right, so we know that I talked about the neuron in previous video, and we know that the charges or the impulses that are sent to the dendrite of the next neuron could be chemical impulses or electrical impulses. Firstly, when an action potential is generated at the hillock of the axon, all right, it travels down the axon until it gets to the axon terminal. So this particular diagram here represents the axon terminal, right? This represents the dendrite of another neuron, okay? So what happens here is that as the action potential is traveling, this voltage gated sodium channels opens up. All right, if you remember when we talked about action potential, I did a video on that. You can go and check that out. So this voltage gated channel flips open, and when it flips open, it allows sodium ion to get into the cell. The same thing happens here. It flips open and allows sodium ion to get into the cell. Same thing. So all the sodium ion enters the cell. All right. And this is only possible when the positivity, the charge in the neuron gets to 55 millivolts. All right. So we know that the resting potential of a neuron is 70 millivolts. Okay. So when the neuron is stimulated and this ion starts getting in, it increases the positivity of the cell. So when it gets to 55, it begins 55 millivolt, it begins to open up this voltage gated channel. It opens up these voltage gated channels and allows the sodium to get in. All right. So when it gets in, the cell becomes more positive. Now, on getting to this point, the sodium channel won't be opening any longer. What is going to be opening now will be the calcium channels. So when the calcium channels flips open, the calcium is allowed into the cell. Same thing happens here and here also. So when this gets into this part, which is axon terminal, something interesting happens. The calcium ion triggers the vesicles. The vesicles. So you have vesicles like this. Now the vesicles contain what we call neurotransmitters. Okay, so these neurotransmitters could be excitatory neurotransmitters or inhibitory neurotransmitters. So I'm going to be using red for the excitatory neurotransmitters. So these vesicles contain neurotransmitters, both excitatory and inhibitory neurotransmitters. All right. So this represents the inhibitory neurotransmitter. Now, when the calcium triggers this vesicle, what do they trigger them to do? They trigger them to begin to move to the membrane, to the cell membrane of the neuron. That's the axon terminal now. So this begin to move towards the cell membrane. And remember, the membrane of this vesicle is a phospholipid layer, same as the membrane of the neuron. Okay, so when this moves to this particular point, it attaches itself to the neuron and empties. They empty their content So the empty, this one empties its content. So they empty their content, which is the neurotransmitter now. They empty the content into the synaptic gap or cleft. All right. This will do the same thing, emptying the content into the synaptic cleft. This the same thing as well. So what happens here is that these neurotransmitters begin to work. What they do is that they begin to bind to the receptors on the dendrite of the next neuron. Okay, so these are the receptors. So these neurotransmitters begin to bind at different receptors. And remember, I said we have both the inhibitory and the excitatory neurotransmitters. Now, the excitatory neurotransmitters are neurotransmitters that will cause an action potential to occur. All right? That means the excitatory neurotransmitters are always the positive ions. So, when this neurotransmitter binds to this receptor, it allows things like sodium into the other cell. Okay? The same thing happens here. It allows calcium into the other neuron. Now, this is for excitatory neurotransmitters. All right? All these are excitatory neurotransmitters, the one that binds to sodium and calcium. Now, we also have the inhibitory neurotransmitter. Let me write that here. What do these do? They prevent an action potential from occurring. All right? Now, this inhibitory neurotransmitter, they bind to the receptors here. And something happens here. This could be the voltage gated channel for potassium or potassium ion. Now, we know that from our previous video on action potential, we know that the potassium ion is always found inside the cell. Okay? So what happens is that the moment this binds, instead of the ions to be taken into the cell, potassium ions comes out, making the cell more negative. Remember, it is an inhibitory neurotransmitter. So it makes the cell more negative. The potassium ion comes out. Now you have other ions like the chloride. So the chloride binds to the receptor as well, and it is taken in. And that is because it is negative and it makes the cell more negative. So that is the inhibitory neurotransmitter. They inhibit action potential from occurring. Meanwhile, the excitatory neurotransmitters cause action potential to happen. So this is what happens between the axon terminal and the dendrite of different neurons that are in close contact. All right, so this is just an overview of synaptic transmission. All right, so see you in my next video.